So my talk tonight is about building this QMX transceiver. I really had two aims in building this radio. Number one, I really gotten into CW. I made my first contact 2024 and just kind of snowballed from there. I am starting to believe that 5-watt CW is like 100 watts single sideband, and I wanted a small compact radio. I have my ICOM 705 I like taking out in the field, but even that is kind of bulky, and I'm not going to leave it in my car. My car's already been broken into. So I just wanted something small that's kind of fit the bill. I think I'm more likely to get out there and get on the air if I have my radio with me. The other aim, going back to 2018, I did a Google search. How can I learn more about electronics? And what popped up was ham radio. I didn't know what it was back then. But that just kind of snowballed. And here I am as a ham radio operator. How can I learn more about electronics? And for me, the answer is doing kit builds, kind of getting out of my comfort zone. As I'm putting something like this together, it's just a matter of looking at each component. What is this component actually doing? Why is its value what it is? And I am no expert, but I did learn a lot, and I'll just pass along some of what I learned. The notable features of this radio, it comes in 3 versions: the low band version, 80 through 20, high band, 20 through 10 meters. I built the mid band version, 60, 40, 30, 20, 17, and 15. So when they call it a 5-band, that's actually 6. It'll do CW mode, digital modes, single sideband. You actually have to choose how you want to build it. You can make it run on 12 volts or 9 volts. I went with 9. I'll show you why. It has a USB-C port on it that you can do cat control through. That also has an onboard sound card for digital modes, which is great. It's a software-defined radio. Interesting implication of that is they release firmware updates that adds new capability to the radio. You just do the firmware update and it does new things. And it's got a built-in signal generator and some testing tools. I'll touch on that a little bit, but after you get your radio built, you're asking yourself, does this thing work? And you can use some of those testing tools and signal generator to answer that. You can see the consumption on receive is 80 milliamps, and with my 9 volt it's drawing about 1 amp. Mine's actually a little under that, about 8.93 on transmit, so you can have fun for a while with a pretty small battery. This radio is sold by QRP Labs. I'm sure a lot of you in here have heard about it. It's a guy named Hans. He's a British operator that lives in Turkey now, where this company has run out of. This website where you order it. So other portable radios that are out there that kind of meet the criteria I was looking for, something like the Elecraft KH1, and you can add a 0 to the price there for what this thing costs. $102 to build it yourself. Not too bad. Kind of okay with leaving that in my car versus like a 705. They will build it for you, but these things sell like hotcakes. It's a small company. And I think they're now shipping orders that were placed in January. So if you want one of these, you can build it yourself or wait a long time to get it. So I opted to build it myself. When you receive the radio, some of the initial build recommendations before you get into it, the main board on this thing is 6 layers thick. It's very good at conducting heat away from the joint as you're trying to apply it. So they recommend using at least a 60-watt soldering iron. The pictures aren't going to do justice to how small this is, and it's a little counterintuitive, but you actually do want a sizable tip on your soldering iron to get the heat in there. You don't want to use a fine tip. You're going to need a digital multimeter. You have to do continuity checks. You won't be able to build successfully without doing that. You're going to make mistakes, so you want to have soldering wick, solder sucker on hand. Good diagonal colors and magnification for sure to inspect your work. I recommend you get a bag of components and you just dump them out. The values on the capacitors are really hard to read, so I recommend just doing that once. Get a poster board kind of sort everything, tape it on the poster board, label what it is. Then you can just kind of walk away from your project, leave the poster there, come back to it. You don't have to sort everything again. They have a fantastic manual. There's some video instructions out there. You really want to read carefully, understand what you're doing, read it again before you do it. These PCB devices were great. I got mine on DigiKey. It was about 20 bucks. You can clamp the circuit board right here as you're working on it. You can put it in there, tape it down if you need to, flip it over, solder, and it's a lot less kludgy than just having it loose on your bench top. So this is what the main board looks like when you get it. It comes as one piece that you have to break apart into the individual components. This is the main board, primarily what I'm going to be talking about. You have a control board where you put the controls for the radio. You can probably see the shape of this. It's eventually going to slide through this spot. This is the topmost board. That's the display board where you install the screen eventually. And you have these two switch mode power supplies. I'll talk about those eventually, but they sit here over this field of surface mount components. You actually have these two little parts right here, which are right here. And again, read the manual carefully because those are very important later on. I'm not going to go into that too much, but if you miss that those are needed, you're kind of hosed. So you get this separated and really want to file the edge as well. I got some jeweler files down at Harbor Freight that I used. This thing is not going to fit well together if you don't get the edges smooth. So that's the main job there. This is what the components look like. It's not that bad. I do recommend sorting them once though. Depending on what kit you buy, you're going to have different capacitor values and different toroids. First step of the build, you put the capacitors in place. You just have to make sure you have the right values there. The manual has them. Most of these pictures are right out of the manual, by the way. It has a more detailed table. You just make sure you get the values right. You don't have to get the orientation in any particular manner there. The diodes, you most certainly do. So the cathode is marked with a stripe, and you need to pay attention to that figure over here on the board. These things are not actually laying down on the board. They are standing up. So with one like this here in the corner, you see you have to put a toroid in there eventually. So I'm going to put the cathode down with the lead that's on the right there through that hole, bend the other lead over just to get the body of the diode out of the way. That's just something you have to pay attention to. One of the more common things that people screw up with this build is getting the diode orientation wrong. You're not going to be able to select the band you want to operate on, mess that up. Throw in some 47 microhenry inductors in there. They're the green things. Those orientations don't matter. That's what it looks like. At this point, Joe was talking about blowing some finals on a Elecraft radio. These are the finals on this radio. So if you run it too hot or too much SWR, these transistors are going to blow. BS170s, put the source gate and drain through the hole. The picture on the bottom left, my pointer is not giving me, it's a little laggy, but that picture there on the bottom left, put the source gate and drain through the hole, bend it over and connect it to the board, the flat spot. The board itself and that washer that you secure it down with serve as the heat sink there. Yeah. So these things take the signal from the exciter, they amplify it to your target output power to go out the antenna. Some people hack their QMXs and they're actually doubling these up to try to get more power out of them. I was happy with a stock build on mine. This is where you make the decision to build this to run on 9 volts or 12 volts. This component, T501, it has its own manual, very detailed. As these wires pass through that toroid, it's a bifilar winding. So on the bottom left, that's the technique you use to make it. Take 2 wires of the right length, make a little loop in one, put it in the chuck of a drill, hold the other end, and spin it until you get about 3 twists per centimeter. Chart on the bottom right there, that is the way that you can wind it. So you have primary and secondary wires there. You have to check for continuity between the points labeled P, so the top diagram in the middle, and continuity between the secondary. You don't want any continuity between S, so you have to remove the enamel from the magnet wire to check for that. Depending on how you pass it through. So the chart on the bottom left, I built mine for 9 volts. If you follow 9 volts up from the x-axis, you can see you get 5 watts of output power. If you build it for 12 watts, a few clicks over, you're actually only getting about 4 watts out. So probably doesn't matter that much, but I went for a 5-watt build, so 9 volts, 3 to 3 winding. At this point, you have to do some continuity checks. The points labeled A on the left, that's where the PA transistors are. And you need continuity over to that other point labeled A. The points labeled B, ground to where that capacitor is. And no continuity between any points labeled A and B. If so, you're good to proceed. I was good to proceed. And then it's time to wind toroids. This is where you spend the most time on the kit. I'm mostly going to be talking about the blue ones in the middle. Those are the low pass, band pass filters, essentially. And some of the other interesting ones, I'm not going to talk about all of them, just the time that you have here. But this is with a main board. My main board actually looked like completely assembled for the 60 through 15 watt version. I mentioned that these are a little different depending on what you go with. It's pretty tight, not a lot of room there. So these guys, you get that chart on the bottom left, but they actually work in pairs. You could see that these two components, L508, 511, work in series to give you operation on 60 and 40 meters. These two work to give you 30 and 20, and then these two get you on 17 and 15. So the manual tells you cut 38 centimeters of wire and make 27 turns and put it in the right spot. This is the technique that I use to do it. I put a chopstick in a bench vise, and that actually worked really well. You can pass through, slide down the chopstick, and it will hold the tension on it so that you can get your other hand free, reposition it, slide it back up the chopstick, make a little room to pass through. It's extremely difficult to count the turns once you've got them on there. So I had a piece of paper and I was just marking it in groups of 5 with tick marks as I was going.
Something I read in that regard, every transition of the end of the wire through the hole is 1 turn.
Right. Yeah.
That's all you got to remember.
Yep. So that's 1 turn right there in that picture. So yeah, easy to screw that up, but be super careful. And one of the other main mistakes people make building this kit is they don't do a good job of getting the enamel off that magnet wire when they solder it to the board. So I used a little butane torch to burn mine before I put it on, and then the heat of the soldering iron does the rest. I soldered it about I think 775 degrees.
Kevin, one more question.
Yeah.
Did you have to use like a hot glue or wax to stabilize the positioning of the toroids so they don't move at all? Because you know what that'll happen, change stuff.
Yeah, I did not.
I did that with mine. I didn't build this particular one. I built
Right.
Right. I had to stabilize it. If I didn't stabilize them, so
Yeah, I didn't do that, but I can say that after I built it, the power output was a little low on some of the bands. So I went back in there and actually kind of squeezed the windings together or pulled them apart. That actually made a difference in the power output. Over time, we'll see if it moves. But they fit in there pretty snug. This one was part of the receive circuit, just one of the other interesting ones. This is a trifilar winding. You saw the drill method for making that winding, but after you're done, you have to figure out which wire is which, make sure they're on in the right place, and you put A to A, B to B, C to C. Once it's soldered in the board, you will have continuity everywhere there between all of those points, and they need to have continuity to that 1 pin on that processor. I was good there. And this is where I screwed up on my build. So the diagram on the bottom right, it's the red component. You can see it's right next to the BNC antenna connection. This is what they call the SWR bridge. It enables sampling of forward power and the reverse power to give you your SWR determination. This radio actually has built-in SWR protection. If it's too high, it'll shut down the transmit. You have to power it down, turn it back on to reset it. So there's wires A and D. Those are 10 turns on each side of the transformer, and then you have those making one turn. It's just a little short piece of wire that you put through there. I don't remember if in my case it was B or C, but I got my radio. It was working wonderfully except for one thing, 0 power output. And this was the problem. I just had a bad solder joint there on one of those one-turn wires. Went back in, soldered in, and now it's working great. So that's it for toroids. We're moving on now to the power supply boards. These guys, they actually fit in here really snugly. These connectors on the bottom, so these pins down here actually fit in these spots right here. So that same connector, the pins here, solder on, I wish I had a laser pointer, sorry. Solder to the pads here.
On the TV, I don't think.
Doesn't show on TV.
Yeah.
It doesn't go. Yeah.
So these boards are sitting above that field of surface mount components. You can see on the top of the screen there's some little nylon washers, and underneath the board there's actually another one of those. So you solder this one in place and just make sure you have good clearance there. Once you have one of the boards soldered, you can remove that nylon washer, pull it off. You got to remember to solder the underside. But these boards act as buck converters. I'm feeding 9 volts in, but there are different components in the radio that run 5 volts and 3.3 volts. And that's what these things do, is step the voltage down to power those things. They have reverse polarity protection. So if you switch up red and black, get the magic smoke, which I've fortunately not done yet in my ham career. These are designed to fail first and protect the radio. You can buy these boards right off the QRP websites. They're cheap to replace. So they do that. And they also, as you do various functions on the radio, like turn it on, it keeps the voltage stable and prevents spikes. So this is what the completed main board looks like. I didn't talk about adding some of the connectors on the side. But you have 3.5 millimeter differing sleeve connections. That's what they actually look like. Never seen one. The DC barrel connector, the bottom left for power. And of course the antenna connection, USB-C connector, top right there comes already installed. You got some of these guys. There are pins on the boards that sit above this that connect to these guys. There's one right here. Shot. Never mind. Bottom center, there's a little black connector there. That's how the power gets up to the boards above. Here's the control board. I'm not going to show the build on that, but you've got 2 rotary encoders, 2 switches. So the big silver buttons there, you can give them a single tap, a double tap, hold them down. That does different functions on the radio, and they obviously turn. The one on the left, that's your AF gain. The one on the right is how you actually tune the radio. And you can see it's sitting above the main board. One of the things you have to do before you apply power is really look at this thing carefully and make sure you don't have any solder bridges or whiskers. It's super easy to do. I absolutely did. Even with handheld magnification, it's really difficult to tell. I work in a lab. I took it to work and looked at it under a microscope just to make sure before I felt confident enough. This thing is really tiny. But that's an important step. That's what it looks like when it's all done and ready to go in the enclosure. So you can see the control board sticking up through the display board. I already explained what's going on. On the left middle, you have a trim potentiometer to adjust the brightness of the screen. That's one of the other things you have to do. After you have it built, it's got a really cool feature, a terminal emulator. So you can connect the USB-C on the radio to your computer. You get a COM port that pops up. You can open up PuTTY and connect to your radio through that COM port. And you just, I I should have mentioned, you also have to install firmware. Go to their website, get the firmware, put it on. But once you're in here, it's really cool, all the things that you can do to test with the hardware tests, verify individual things. As mentioned, there's a signal generator in the radio that will send signal through needed components. It can generate RF on a dummy load. The manual shows you what all these tests should look like, and you can compare it to what you're getting. That's how I determined how my radio was not outputting any power back end. You can calibrate the single sideband and also check your mic gain adjustment. You can talk into your microphone and actually watch a chart going by to see where your voice peaks are. Otherwise, you have to get on the air and ask somebody, how do I sound with 5 watts? You can also enter messages. So if you want to put your CW messages into the memory, it's a lot easier to do it here than on the radio. I mentioned it does single sideband. For much of this radio's life, it didn't. But as of last May, they released a firmware update that it enabled it. So everybody that already had one of these radios out in the field, they had single sideband. It's actually uses polar modulation to do the single sideband. The other radios out there that are doing this are flex radios, kind of high-end radios. It's just very efficient. Generates less heat, uses less power as compared to linear amplification for single sideband. The one catch is there's no microphone available, so you have to make your own. If you're into 3D printing for ham radio, you know who K6ARK is. People have probably heard of him, but just go to printables, and he's got this case on the right. And here's the microphone. It's pretty small, so I 3D printed a bunch of those, and if I go on DigiKey to buy a mic element or switch, I don't buy one. I've got a ton of these, so if anybody builds one of these radios, you want to let me know. I can get one to you pretty quickly. So yeah, my radio was built. There it is out in the field. I took it out for a Parks on the Air activation, went up Lacey Road in Robinson Howe State Forest. Nice and high in elevation. I was on the air for just under an hour. Using 5 watts, went to the Parks on the Air website, spotted myself, told people I'm on this frequency, come find me and make contact with me if you can hear me. There's an ever-growing body of people out there that are doing that these days. In that hour, I quickly made 10 CW contacts, but I spent the bulk of the time trying to get single sideband contacts. I am not a fan of QRP single sideband. I was figuring I was going to get like 3 contacts, but I actually ended up getting 7. I was quite happy with that. The one thing the radio doesn't have is a speaker, so you have to have an external speaker. Here's mine. Just keep it right next to myself so I can put it down and listen to those weak signals. But yeah, it's a very small kit. This is everything I need to get on the air, with the exception of maybe an arborist throw line to get this antenna up in a tree or a mast. So super compact kit.
If you walk right back there, that's the turnaround. That's my rope. That's where my antenna rope is, right there.
Okay. Apparently it's a touch screen.
Realize it.
All right.
That's all right. So yeah, I've got some QSO maps, the one for my POTA activation. One of the CW contacts I made was actually in Sweden, just after the blue. I got a 559, really. That's SM3NRY. You probably worked him before, but he's got an incredible station. He was doing the heavy lifting there. And just hunting from home with this radio on the right contacts that I've made through my off-center fed dipole. Very satisfying to go out and make contacts on a radio that you built. The last thing I would say, this is my last slide, is just getting the digital modes up and working. As mentioned, it will run WSJTX no problem via cat control, but there are some applications that people are releasing to work with this radio. One of them is IFTX. So I can actually do FT8 right off of my phone, which I thought was pretty cool. All of the troubleshooting that I had to do to get this working was on the iPhone side of things. It just does not play nice with ham radio. Long story short, what eventually worked is getting an OEM Lightning to USB camera adapter. Just a straight cable won't do it. It doesn't know that it should send the audio signal through that cable. It just plays it through the speaker. So you have to have the right resistance in the cable that it says, oh, this is a headphone. Headphone connections wouldn't work for whatever reason this thing did. So I did a bunch of testing with that on a dummy load. First time I called CQ, I made a contact in Florida, got a -5 dB signal report there. So I was pretty happy with that. That's a cool little app. You set the radio to work in Fox so that it triggers transmit when you transmit. On your phone, you got a little waterfall on the bottom. You just use your finger to kind of find a gap and set your transmit frequency. That's pretty cool. So if I'm struggling to get an activation done, I can jump on FT8 and bang out a few. That's my presentation.